Adam Kemp, and today we're learning about how to make a battery. In this clip, we're going to take an ordinary household potato and turn it into a voltage source powerful enough to drive an LED. To start off, you need to get a regular household potato and cut it in half. Because a household potato is relatively large, we don't need the whole thing, and we can use the two halves to make two voltage sources. So if you go ahead and cut your potato in half, you'll start to notice that they're relatively juicy. Now, I don't think potatoes are known for their juices, but that's exactly what is going to act as the electrolyte we need in order to produce that electron flow between our anode and our cathode. And with a potato, that electrolyte consists of phosphoric acid. In order to produce the anode for our battery, we're going to need a nice shiny penny. And if you can't find a shiny penny, if you take some of the steel wool and gently rub back and forth on the penny, it's going to remove a lot of the oxidation that's going to inhibit producing a nice cathode for a battery. Now, if you take your knife that you used to cut the potato apart and make an incision in one side of the battery, you take your penny and gently insert it into the battery so far that you've got just a little bit of that piece of that penny sticking out. Now, the further you get the penny into the potato, the more contact that the copper has with the phosphoric acid inside of the battery. Next, you're going to produce the cathode by taking the galvanized steel nail and driving it into the other side of the potato. At this point, it's very important that the cathode doesn't touch the anode. If the two touch together, you're not going to produce an electric circuit and the battery won't work. Now, if we take our multimeter and move our range selector to the 2 volts range, we'll see that we've got a red and a black lead on our multimeter. This indicates which go to the anode and the cathode. If we attach the black one to the cathode and the red one to the anode, we'll see that we're producing a good bit of voltage. And in this case, we're producing about 0.58 volts. If you drive that zinc a little bit further in, make sure your penny's in there, you should be able to get a little bit more voltage out of it. And we got about 0.2 volts more out of this potato battery. If we think back to when we were illuminating an LED, we're going to need 1.5 volts and about 10 milliamps of current. And in order to do that with a battery that's producing anywhere between 0.5 and 0.75 volts, we're going to need a lot more potatoes. Here we have 6 half potato batteries that I'm going to orient in both series and in parallel in order to get enough voltage and current to drive an LED. If we take our multimeter, we can measure the voltages coming out of each battery, and if we put the red on the anode and the black on the cathode, we'll see that we're getting about 0.63, about 0.58 volts, about 0.65 volts, about 0.63 volts, about 0.62 volts, and 0.9 volts. That's my good battery. In order to produce the 1.5 volts necessary to illuminate the LED, we're only going to need 3 of our potato batteries. If we take these 3 batteries and align them in a series fashion, we're going to produce approximately 1.5 volts, and we can measure that with our multimeter. To start off, I'm going to take one of my leads and I'm going to connect it from the anode to the cathode of the other battery. I'm going to follow this step for my third battery. And what I'm left with is an anode on one battery and a cathode on the other. And they're almost oriented in a single file line. If I take a final 2 electrodes, and I like to use red and black, black indicating the cathode, red indicating the anode. And what I'm left with is 2 leads proper to connect to an LED. Now I can take my multimeter and measure to make sure that I'm achieving the required voltage. And if we see on the multimeter, we're getting about 1.67 volts, which should be proper in order to illuminate the LED. If you look at an LED has an indication that tells you which side is the anode and which is the cathode. Normally, if it's a brand new LED, one leg will be slightly longer than the other leg. The longer leg indicates the anode, while the shorter leg indicates the cathode. On most LEDs, there's also a flat side that looks like a minus sign that indicates the cathode. If we connect our leads now to our LED, I can see that it's illuminating very dim, but it is illuminating nonetheless. If I show the camera, you probably won't see anything. If we want to make it brighter, we've got 3 extra potato batteries that we can align in parallel with these 3 batteries in series that will give us the required current to make the LED brighter. In order to do that, I'm going to separate these batteries from their series fashion and I'm going to split them up into pairs. Each pair of batteries is going to be oriented in parallel, and then we're going to connect them all together in series. In order to connect 2 batteries together in parallel, you're going to connect their cathodes to each other, and you're going to connect their anodes to each other. And if we recall the first clip, I've outlined that connecting batteries in parallel doesn't increase their voltage, it increases their current. So by connecting 3 pairs of parallel batteries together in series, you're going to increase their voltage and increase their current. Now that we have 3 pairs of batteries connected in parallel, in order to increase the current, which will make the LED brighter, we need to connect these 3 pairs in series. All we need to do that is connect the cathode on one to the anode on the other, and then repeat the step until you've completed connecting the 3 pairs of batteries in series. And what we're left with is only one anode and only one cathode. Now, if we take and connect the LED to our new mega battery and see if it shines any brighter. And what I'll do is I'll flash the LED on and off to see if the camera can see it. And as you see, the LED is shining a lot brighter than it would have if we only had 3 batteries in series. So we've increased the voltage by putting the batteries in series and increased the current at the same time by putting them in parallel. Coming up in the next clip is an overview of how to make a lemon battery.
To watch the other